This video is on how to use the quadratic formula. There's another video on how to derive the quadratic formula. So the quadratic formula is used to find the roots of an equation, and I'll explain more about what that means by the end of the video. So it works on quadratic equations. Quadratic equations must have the leading coefficient, the leading exponent this is a second order equation and then it has three terms. But in order for me to have this in the form where I will have the A, B, and C to plug into the formula, this has to be set equal to 0. In order to set this equal to 0, I need to move the 6 to the other side. So I'm going to subtract 6 from both sides of that equal sign there. And that's going to give me x squared plus 2x minus 8 equals 0. Once it's in this form, then I can identify what the A, B, and C are. The coefficient of the first term over here is a 1. So this is our A term or B term. I forgot my x here. This is the A term, the B term, and the C term. So for the A term, A equals 1. For the B term, B equals 2. And the C term is minus 8. Once I have these, I just go back to the original formula and I plug them in. I'll try my best to do the color coding here. So I have minus b, so that's minus 2, and then it's plus or minus the square root. And this here, the b squared is 2 squared minus 4 times a, which is 1, times c, which is minus 8. Make sure you keep track of the negatives. Now, this piece over here under the radical is known as a discriminant, and the discriminant is going to have two roots. One will be positive and one will be negative. Just think about this. If I had minus 4 times minus 4, well, that would give me 16. But if I also had positive 4 times positive 4, that would also give me 16. So if I was taking the square root of 16, I can have two roots. One of them is positive, and one's positive, one's negative. So now this entire numerator is over 2 times a, and a is 1, so I just put times 1 here. So now I've substituted everything in. Now it's just algebra manipulation to get our answer. So we'll stay with one color, just to do it faster. So I have minus 2 plus or minus the square root. Now you can go off to the side and do this separately. I'm going to do it under here. So 2 squared is 4 minus, and I have 4 times 1 is 4 times minus 8 is minus 32. And since the entire thing is negative, it's going to become plus 32. And this entire thing is over 2. And then simplifying further, I have minus 2 plus or minus the square root of 36 divided by 2. Now, we don't need this over here, so I'll just get rid of that. So now this over here is going to be minus 2 plus or minus the square root of 36 divided by 2. Now this can have two possible answers. Answer number 1, I would have minus 2 plus the square root of 36, which is 6, divided by 2. So then I have minus 2 plus 6, which is 4 over 2. So this root is going to be a 2. And then the second case is minus 2, and instead of plus the square root of 36, this one would be minus the square root of 36, which is 6, divided by 2. And then this is going to be minus 8 over 2, which is equal to minus 4. The roots of an equation, what is meant by this is that these are the values that if I substitute them in for x, then this equation would be equal to 0. So we want this statement to be true. So I'm going to substitute in the 2 there. So I have 2 squared plus 2 times, and then this over here would be a 2 in here. So once I do the algebra, I have 4 plus 4 minus 8 equals 0. And 4 plus 4 is 8. 8 minus 8 is 0. So this one checks out. This is correct. I'm now going to substitute to check the minus 4. So I have minus 4 squared. I want to maintain the color coding here. So I have minus 4 squared plus 2 times minus 4 minus 8 equals 0. So minus 4 squared is going to be 16 plus 2 times minus 4, that's minus 8. And then I have a minus 8 equals 0. And then I have 16, and then positive times a negative, so I have minus 8 equals 0, and minus 8, this is 16 minus 16 equals 0. So the roots of this one checks out. The roots of the equation are simply the values you would plug in for x that would make this equation, in fact, equal to 0.
That was easy.